Hey everyone, and welcome. Today, we are going to tackle one of the biggest questions in any math class, and that is, when am I ever going to use this? Well, you're about to see how all those curves and equations, those quadratics, actually leap right off the page and into the real world. Let's dive in.
You know the feeling, right? We've all been there, staring at an algebra problem, wondering what on earth this has to do with real life. And you know what? It's a totally fair question. The answer, though, is pretty amazing. It's literally all around you, shaping some of the coolest things we see and do every day.
No, seriously, the very same math that you use to figure out the arc of a basketball shot, that's what engineers use to plot the path of a rocket. It's how businesses figure out that perfect price point to make the most money, and it's even how those massive, beautiful arches on bridges are designed. This isn't just boring theory. This is the engine behind engineering and economics.
Okay, so if this math is so powerful, why does it feel like such a puzzle in class? Well, here's the secret. The barrier isn't usually the algebra itself. It's the translation. It's turning a real-world problem into a language that math can actually understand.
This is hands down the hardest part. You're reading a word problem about a rocket or a garden, and you're supposed to somehow pull a clean, solvable equation out of it. It feels like you need a secret decoder ring. Well, today, I'm going to give you one.
And this is your translation key. This simple little dictionary tells you exactly what a word problem is asking for. Anytime you see words like maximum height or max profit, boom, you know you're looking for the vertex. If it asks, when does it hit the ground? You're finding the roots or the x-intercepts. An initial or starting point, that's just your y-intercept, that c-value. Just like that, we've cracked the code.
All right, theory's great, but let's put it to the test. We're going to take our new dictionary and use it on 3 classic problems, just to see how powerful it is at turning confusing sentences into clear, simple answers.
First up, the all-time classic, the rocket launch. So imagine a rocket is shot up from a platform 80 feet high with an initial speed of 64 feet per second. The question is twofold. When does it reach its max height, and what is that max height?
And this is where our dictionary is a lifesaver. The phrase max height immediately tells us, find the vertex. So, using that handy vertex formula, negative b over 2a, we get the x value, which in this case is our time. And the answer, 2 seconds. That's the win. Then, to find the what, the actual height, we just plug that 2 back into our original equation, and we find out the rocket's max height is 144 feet. See? Simple as that.
Next, let's use our dictionary on a geometry problem. Let's say a farmer has 100 meters of fence and wants to build a rectangular pen that has the absolute biggest area possible. What are the dimensions?
So first we have to set up our quadratic equation for the area. But once we have that, the key phrase maximum area points us right back to our good old friend the vertex. A cool trick here is to find where the area would be 0. That's at a width of 0 and a width of 50. The vertex is always smack dab in the middle of those 2 points, which is 25. So the best width is 25 meters, which means the length is also 25 meters. A perfect square gives him the biggest bang for his buck.
Okay, for our last practice problem, let's jump into the world of business. A factory's daily cost to produce items is modeled by a quadratic equation. The goal is to find how many units they should make to have the lowest possible cost.
Yep, you guessed it, just like maximum, the word minimum is another code word that tells us to find the vertex. This time, the parabola just opens upwards. We use our trusty formula, and we find the x value is 20. That means producing exactly 20 units is the most efficient. And what is that minimum cost? We just plug 20 back into the equation and find out it's $100.
So knowing the method is half the battle. The other half is knowing how to avoid the simple mistakes that can trip anybody up. Let's talk about the 2 most common traps in these kinds of word problems.
The number one, without a doubt, biggest mistake is answering the wrong question. Always, always, always double check what you're being asked. If the question is when or at what point, they want the x value. If it's how high or what is the profit, they want the y value. It's such a tiny detail, but it makes all the difference.
And the second trap is forgetting about common sense. When you solve for when a rocket lands, for example, the math might give you 2 answers, say 5 seconds and -1 second. Now, math gives you both options, but you know that time travel isn't a thing yet. So you have to apply your real-world logic and toss out that nonsensical negative answer.
Okay, so we've seen how to nail these homework problems, but what's the real payoff for learning this stuff? Let's scale this up from a classroom problem to a high-stakes, real-world business decision.
So picture this. You're running a huge concert venue. You have to decide on the ticket price. Your goal is to maximize your revenue. This isn't just a random guess. It's a math problem, a quadratic problem, to be exact.
Here's how it works. Revenue is just your price times the number of tickets you sell. Now, if you raise the price, you're probably going to sell fewer tickets. If you lower the price, you'll sell more. That trade-off creates a perfect quadratic relationship. And if you build an equation for that, the vertex will tell you the absolute perfect price, the sweet spot, that will make you the most money possible.
And don't underestimate how valuable this is. In the real world, businesses pay analysts millions of dollars to run these exact kinds of calculations. Getting that pricing model just right can be the difference between a company having a good year and an absolutely incredible one.
So there you have it. We went from the basic, when will I use this question, to getting the tools for translation, all the way to $1 million business application. You now have a totally new framework for looking at the world around you.
Look, this was never just about passing a test. It's about learning a new way to see and solve problems. You've got the dictionary, you know the method, and you've seen the real-world power of this stuff. So the only question left is, what problem are you going to solve?